Ever clicked your mouse and just wondered what actually happens inside that box? It feels like magic, right? But it's not. It's really this incredible, high-speed performance with a whole team of components working in perfect sync. In this explainer, we're going to pull back the curtain and meet the team that makes it all possible.
You know, the best way to think about your computer isn't as just one thing. It's much more like a perfectly coordinated team of specialists. Seriously, each member has a very specific job, and they all work together at just mind-boggling speeds to get things done for you.
So who are these team members? What do they all do? Well, that's exactly what we're about to find out. We're going to meet the brain, check out its workspace, figure out how it senses the world, and get to know the project manager that keeps the whole show running.
And you know, this team isn't just thrown together at random. Oh no. It's all assembled according to a master plan, a blueprint, called computer architecture. This is what lays out exactly how all those different hardware parts are going to work together to create the machine you're using right now.
Okay, so let's start with the undisputed star of the team, the brain of the whole operation, the Central Processing Unit, or as we all know it, the CPU. This is where all the real thinking happens.
For a long time, the game plan was simple. Just make this brain faster. And for a while, it worked like a charm. From the mid-'80s all the way to 2002, processor performance grew by a staggering 52% every single year. Just try to imagine getting 52% better at your job year after year. It's wild. But that amazing run just couldn't last. After 2002, we started hitting some real physical limits. Things like heat and how much power these things were sucking down. That incredible growth, it slowed way down to just 22% a year. The whole just make it faster strategy had pretty much hit a brick wall.
So the industry had to get clever, and the solution was actually pretty brilliant in its simplicity. If you can't make one brain faster, why not just use more brains? And that right there kicked off the era of parallel processing, using multiple processors, what we call cores, all working together on a single chip.
And it gets even cooler. They figured out how to make each one of those individual brains a better multitasker. It's called multithreading. It's what lets a single core in your CPU juggle multiple tasks, or threads, at the exact same time. It's literally the reason you can have music playing while you're typing in a document and nothing grinds to a halt.
Now, this multitasking comes in two main flavors. Fine-grained is kind of like a hyperactive juggler, switching between tasks on every single little instruction. Coarse-grained is a bit more patient. It only switches when there's a big pause or delay. Both are just different strategies to keep that processor as busy and as efficient as possible.
Okay, so we've got the brain, but where does it do all this amazing thinking? Well, every genius needs a workspace, right? And for the CPU, that workspace is memory.
And there are two main parts to this workspace. Think of it like this. Primary memory, what we usually call RAM, that's like the CPU's desk. It's where it keeps everything it's working on right now. It's super fast to get to, but when you turn the power off, poof, the desk gets wiped clean. Secondary memory, things like your hard drive or SSD, that's the long-term filing cabinet. It's a bit slower, sure, but it's where everything is stored safely, even with no power.
And inside this workspace, you've got different tools for different jobs, and each one has its own trade-offs between speed and cost. You have ridiculously fast cache memory, SRAM, which is kind of like having sticky notes right on the CPU itself. Then you've got the main desk, the RAM, and for that big filing cabinet, you've got things like flash memory, what's in your phone, or those massive magnetic disks for storing tons and tons of data cheap.
All right, our team has a brain, and it has a workspace. It can think, and it can remember. But how does it actually interact with the outside world? I mean, how does it listen to you or show you what it's been working on? That's where the senses come in. Input and output, or just I/O.
So for the CPU to talk to your keyboard or your screen, it needs this special little mailbox system. It uses things called registers to send and receive info. One register holds the actual data, and another one checks the status. It's like a way of asking the device, hey, you ready for this?
Now, the first try at this was, well, let's just say it wasn't great. It was called busy wait. I want you to picture the CPU just staring at the keyboard, constantly asking, are you ready yet? How about now? Now? It is just wildly inefficient. Our super-fast brain, the CPU, is completely tied up doing nothing but waiting around.
Thankfully, someone came up with a much smarter solution: interrupts. So instead of the CPU constantly asking, the device itself sends a signal, an interrupt, when it actually needs attention. It's basically a doorbell.
The CPU can go off and do a million other useful things, and it only answers the door when somebody actually rings. So much better.
And this led to a way more elegant system. The device sends out an interrupt request, and the CPU shoots back an interrupt acknowledge when it's ready to listen. This simple little back and forth is absolutely fundamental to how modern computers can multitask so well. So we've got the brain, the workspace, and the senses. But who's in charge? Who coordinates this all-star team and makes sure the CPU is working on the right thing at the right time? Well, that's the job of our conductor, the operating system. The easy-to-use systems we have today are really the result of a long and pretty fascinating history. It all started with these command line systems like Unix back in the 60s. Then in 1981, Xerox pioneered the graphical user interface, the icons and windows we all take for granted. That idea was then made super popular by Apple's Mac OS in '84, followed closely by Microsoft Windows in '85, and then the open-source Linux kernel in '91.
At its heart, the OS is the master multitasker. Its whole job is to manage all the different programs or processes that you're running. It carves up the CPU's time, decides which task gets to go first, and even helps them talk to each other, all while making the whole thing feel totally seamless to you.
Now, to pull off this incredible juggling act, the OS does something called a context switch. It's how the CPU stops working on one thing and instantly starts on another. It has to pause the first program, save its entire current state, its context, and then load up the context for the next one. This happens thousands of times a second. It's the trick that creates the illusion that you're doing everything at once.
So there you have it. The CPU as the brain, memory as the workspace, I/O as the senses, and the OS as the conductor. It's this incredible team, all working in perfect harmony, performing literally trillions of operations every single second. It's an absolute masterpiece of architecture. And the most exciting part is that this team is always changing, always evolving, which just leaves us with one big question. What will the next generation of this team be able to do?